like this. On an inclined plane, there is a fixed pulley, 20 kg mass is hanging vertically, not in touch with the surface, vertical surface. This and this, they are touching each other. It's only so that diagrammatically we can draw the forces. I have created some space. Coefficient of friction between this and this is 0.1. We are asked, what is the tension in this string? So what we do is, that is, we see this side the force is 200 Newton, which is trying to move the system this way. And we also see that is a force component of weight in this direction is mg sin theta. M into g we are taking as 10 into sin 30 is half. So this is 50 Newton is the component of weight. That is, over here we have seen this is 100 Newton. Mg cos theta will be over here. Mg cos theta, that is this component, mg cos 30, m is what? 10 into g is 10, cos 30 is root 3 by 2, and we have just done, this comes out to be almost equal to 87 Newton. So this comes out to be 87 Newton. And this goes off. Whether either you can have a resultant force or you can have its components. This force mg is represented by these two components. So along the string, if we observe, that is, this side the force is 200 Newton and this side the force is 50 Newton. So it means the system will have a tendency to move in this direction. So from here we can find the direction of friction force between this block and this block. Now the interlockings, they are like this. This block is trying to move this direction, in this direction. So as a result, this block pushes this inclined plane irregularities in this direction, and these irregularities, they push it back in this direction. This block has a tendency to move this way. Friction force will always resist the relative motion. So as a result, the direction of friction force is in this direction. So once the direction of frictional force is established, now we come to its maximum value. Let's see what is the limiting value of friction force. Limiting value of friction force, now the normal reaction. The limiting value of friction force, we know it is mu into n. Mu is given as 0.1, and as far as normal reaction is concerned, this is x-axis, this is y-axis. 80 Newton is this way. This applies as normal reaction n1 onto this inclined plane, and this applies n1 onto the block in this direction, that is perpendicular to the interface. This block is neither going up nor going down, so it means normal reaction n1, it has to be equal to n1 is going to be 87 Newton. Normal reaction is 87 Newton because there is no motion on the y-axis. Along the y-axis we have only two forces. One is n1, the other is component of weight in this direction, that is 87 Newton. So 87 is going to be n1. So the limiting value of friction force is mu 0.1 into 87. That is 8.7 Newton. So it comes out to 8.7 Newton. So now we have to see, that is, whether the system will be moving in this direction or it will be stationary. We say that is, this way side is 200 Newton, this is 50 Newton, and let's say it uses maximum value 8.7 Newton. Suppose it uses maximum value, and from here we can see, that is, whether the system shall be now be moving or not when it reaches its maximum value. So over here we observe that this side is 200 Newton is good enough to overcome this 50 Newton and 8.7 Newton. It can easily overcome. So as a result, the system will be moving in this direction, and equation for this block now will be 20 minus T is equal to mass 20 into acceleration. Whatsoever will be the acceleration of this block in this direction, from here to here there is single string. String is ideal, inextensible, massless, so it will also have an acceleration in this direction. So for this, T is in this, from here to here is one string only, tension is always outwards, so T is this way, T minus, what are forces in this direction? One is mg sin theta, that is 50 Newton, plus limiting value of friction force, that is 8.7, is equal to mass. Mass is 10 into weight. So now you can easily add these two, and you can get the value of tension also, and you can get the acceleration value also. So we have just done this case where the force was 200 Newton and over here it was 50 Newton. Mu we had taken 0.1 and this came out to be, let's say, 8.7 Newton or so. As a result, the system was accelerating in this direction. What if the value of mu is so large that, let's say, this friction force, the value, it comes out to be 170 Newton. Suppose the limiting value, F limiting, I am we are considering a case where the mu is so high so that mu into n, the limiting value of friction force, let's say that comes out to be 170 Newton. So in that case, what will the tension? In that case, we observe that is 200 Newton is the force which is trying to move it this way, and this way the maximum value 50 plus 170, that is 120 Newton. We cannot make a mistake that this side the force is 200 Newton and this side the force is 50 plus 170, 220 Newton. So this will accelerate this way. Please understand that first we do not take the frictional force into consideration. We see that is which way the system has a tendency to move. This is 200 Newton, this is 50 Newton. So system has a tendency to move this way. So either the system will move in this direction or it will not move. These are only two things which are going to happen. The limiting value of friction force comes out to be 170 Newton. So now this force is not sufficient enough to overcome this and this force. So it means the system will not move. It means that this friction force, limiting value of friction force, that was equal to 170 Newton. So now this friction force will self-adjust itself so that the blocks, they remain stationary. So now this will adjust itself to 150 Newton instead of 170 Newton. It will come out to be 150 Newton, 150 plus 50, 200, 200 is this way, 200 is this way. As a result, now the system will be stationary. It will not be accelerating. So this is self-adjusting case. So this case will be of self-adjusting. And if someone asks what is the value of friction force between this and this, you will not say 170. 170 is the limiting value of friction force. The friction force between this and this block, that is 10 kg block, and this is going to be 150 Newton.